Question B. All right, so I wish that there's more light so it didn't always look like I was in a cloud. Anyways, who cares about that? Set the original chipboard from question A. So I'm going to go with the fact that we're at -4. Find 3 ways to get a total of -2. So if I reset the board, and here I cleaned up the board, that was not my finest moment. That's the way it goes. Here we go, so setting it back up again. So 2, 4, 6, 8, 10, 12, all right. So here we have our original board. And we are to find 3 ways to get a value of -2. Well, right now we have a value of -4. Well, I could subtract 2, couldn't I? So that means one way I could do this is I could go -4 minus -2, because I subtracted 2 red chips, and that is equal to -2. All right, let's try to find another way, shall we? So we're at 8 and 12, right? I need to get -2. Well, I could add 2, couldn't I? And that gives me my -2. So I could also say -4 plus +2. Now normally you wouldn't put plus positive, but you know what, for this it probably makes sense to do so. Let me make my pen a little bit thicker so it's easier to see on the video. And that is equal to -2 again. All right, now a third way of doing it. Oh boy, how are we going to do this? So I'm going to reset the chipboard. I'm going to take the 2 that I added and put them away. All right. So I did this with subtracting. I did it with adding. Oh boy. Well, I have an idea. We said that if we pair these up, each pair is worth 0, right? So what happens if I add? What happens if I add 2 zeros? Have I changed the value of my chipboard yet? No, I haven't. Okay, so then we need to get it to -2, right? So that means I could just, well, we still have this, take these 2 away, and that would work, wouldn't it? All right. All right. That idea of adding numbers or adding 0 is going to be a big idea when we start talking about some other problems. So I'm not writing this one out. Really, the big idea is you can add zeros by adding a red and a blue together. Okay? So let's take a look on how that's going to affect problem C. Give 3 combinations of red and black chips. Sorry. Okay. All right. So here we go. Give 3 combinations of red and black chips that use at least 1 of each color. Okay. This is kind of a boring problem because clearly I can add 1 red and 1 black, or 2 blacks and 2 reds, or 3 blacks and 3 reds. Same basic idea here. I could have 13 blacks and 1 red, 14 blacks, 2 reds, and that's a really easy way to think about it. So I'm not really going to spend a whole lot of time on this problem. It doesn't really help me go forward. I trust you did that right. Okay. How about question D? More interesting problems. All right. So describe a chipboard and display that the matches each number sentence. Find the missing value in each case. So I'm going to actually use a chipboard here for all of these. So my first question is asking me to find. So we start with 3 positives. And, oh, actually, you know what? I have a better idea. So question E, I'll just do it this way so you can see the problem. All right, so we are going to start with 3 positives, because that's the first number that shows up. 1, 2, 3. And I'm going to take 2 positives away. I'm going to do that by just going 1, 2. What's left? 1 positive. No surprise there. All right, let's try. Let's try number 2. We're going to start with negative 4. 1, 2, 3, 4. And we're going to take positive 2 away. Whoa! How can I take 2 positives away if I have 4 negatives and no positives? It's not possible. Maybe it is possible. Remember when we talked about adding zeros? Like I could add 0, right? Does that change? Is this still 0? Yeah. Have I changed the value of the chipboard when I add those? No, it's still 0. So, I can take positive chips that I don't have away if I add zeros to it, can't I? Okay, cool. So here we go. So we have 4 negatives, and I need to take 2 positives away. So if I add a 0 and another 0, have I changed the value of this chipboard yet? I haven't. So now I have these 2 positives that I can kick to the curb. And I'm going to do that actually physically so we don't get confused if we can't see the colors too well. So now what am I left with? I'm left with 4 plus 2 reds. That's 6 red, that's negative 6. So negative 4 minus 2 is going to be negative 6. Well, let's try number 3. Number 3 is kind of that weird setup where you have subtracting negatives. I believe you and Ms. Hannah's talked about this before, but just in case, let's give it a shot. All right, so we have a negative 4, so I'm going to put in the 4 negatives. 1, 2, 3, 4. And we're going to take, those are positives. So 1, 2, 3, 4. So we have 4 negatives. Excellent. And now we're going to take 2 of the negatives away. 1, 2. What are we left with? Only 2 negatives. That's more than 4 negatives, isn't it? So now we are going to have a larger result. All right. So now we come to problems that have multiple possible solutions. Those are always kind of fun. All right, so we're going to start with 7 negative positives. 2, 3, 4, 5, 6, 7. All right, and we need to get to a result of positive 1. Well, one thing I could do is, oh, wait a second, it says adding. So I have to add in this case. I cannot subtract. Oh, so I guess there's only one way to do this then. Well, if I add a negative, that will pair these off, won't it? So how many I've added? 4, 5. If I add 6 negatives, then I still have 1 positive remaining. So that will be plus 1. So I added 6 negatives. All right. Negative 3 minus 5 positives. All right. I swear half this video is you watching me clean up chips. All right, I'll put the black one. All right, so we have negative 3. 1, 2, 3. And we're going to take 5 positives away. But I don't have any positives to take away. But we know the trick now, don't we? We can add zeros. Here's 1 0. Here's 2 zeros. 3, 4, 5. So now I have 5 red chips I can take out. So take them out. 1, 2, 3, 4, 5. And what am I left with? I'm left with a total of negative 8. Whew. Finally, last one. getting tired already. All right, so we have something, and we're taking 2 negatives away, and we're getting 6. Well, if I have, so now I have 2 negatives to take away, and this board is worth nothing. Well, I need the board to be worth 6, right? 4, 5, 6, right? Now, if I take these 2 negatives away, the board will be worth 8, right? So really, I need these out. So that allows me to take 2 away. So that means if I start with 4, start with 4, and I subtract -2, I will get 6.